Hello everyone. The question that I chose is from Module 6, Work and Energy, and this question was number 14 on our homework. And the question states, a 67.5 kilogram hiker starts at the elevation of 1210 meters and climbs to the top of a peak 2790 meters high. So on part A, we are asked what is the hiker's change in potential energy. So when we need to think about is the potential energy at the peak of the, so let me draw this so we can have an idea. So here's our hiker. We need to think of the change that is at the peak, potential energy change at the peak and the potential energy change at the initial. And we have given those two values, which is 1210 meters when he starts and he ends at 2790 meters high. So we know that the potential energy is equal mass times acceleration due to gravitation and height. We have given the values of the mass, which is 67.5 kilogram, and we have given we know the gravitational due to acceleration is 9.8 meters per second square, and we have two heights at the initial, which is 1210 meters and 2790 meters at the peak. So we need to think of both of the potential energy. So I'm going to put HI for here and potential energy for M times HF for the final. So we have delta P in here, which is going to be potential energy of the final minus potential energy of the initial height. And plugging in our expressions in here, we have mg hi minus mg hf, and we can continue, we can combine like terms, and doing so we simplify this expression to mg hf minus hi, and we from now on we can just plug in our values. We have the mass, which is 67.5 kilogram. We have 9.8 meters per second square for our acceleration due to gravitation, and we have 2790 meters for our final height minus 1210 meters for our initial. And solving this, we get 1.05 times 10 to the 6 joules, and this represents our solution for part A. Now in part B, it's asking what is the minimum work required of the hiker. And if we think back to our work energy theorem, we know that work is related in changes in energy. So in this case, we have a change in potential energy. And the energy required to increase the potential energy of the hiker must be work done by the hiker. So the minimum amount of work done by the hiker must cause the change in potential energy. So for part B, so the minimum work done by the hiker must be equal to delta P. So we have work is equal to potential energy, and we already solved for potential energy, so our answer is the same as part A, and it's 1.5 times 10 to the 6 joules. On part C, we're asked, can the actual work done be greater than this? And the answer is yes, because more work can be done by the hiker. Yes. Because there is inefficiencies when the hiker is trying to move uphill. If there was no loss of energy, then the work done by the hiker would be exactly equal to his change in potential energy. But we know in real life that the hiker is losing energy in some way. There is an efficiency of him having to work against a wind resistance. Maybe he needs to wear off to the left or right, or climb up and down. All these inefficiencies would result in a hiker doing more work than the minimum required. Thank you, and I hope you enjoyed it.